In addition to the simple coil, there are many variations of coils available in the ladder logic. Some that we'll look at are negated coil, set coil, and reset coil, just as a sample. But first, we're going to examine the PLC conceptual view and also a bit about inputs and how they're combined. The physical inputs and outputs connected to a PLC are not directly manipulated or read in the PLC program execution. So what happens is when a cyclical process, whenever the PLC is in run mode, where the output memory bits are mapped to the physical output, so a 1 corresponds to an on and a 0 would generate an off on that output. And then all the inputs are evaluated and are assigned to input memory bits. So if the input is high, then that bit is assigned to 1. If it's low, it's assigned to 0. After all those assignments are complete, then the ladder logic program is executed. And this program only manipulates bits in memory. It doesn't change physical values. So if an output is to be set true, then a 1 is assigned to that memory bit. After all the instructions in the ladder logic program have been executed, then again the bits in the output memory are mapped to the physical values. So a 1 would give you 1 on that high voltage on that output, or an on that output, and a 0 would make that output off. It's often common to need to combine inputs in some logical sequence or logical manner. Here's an example of AND logic, so AND Boolean operation. And as a physical example, we have this two-hand safety switch. This is designed to keep the operator's hand away from machinery while it's being operated, and it requires that both buttons be pressed before the machine will move. The guards over it are to ensure that the operator doesn't design some kind of board to allow her to press both buttons at one time with just one hand. Now in ladder logic, that would look like two switches on the same rung, so in series, and this is the equivalent of a Boolean AND operation. So we'd have here examine if closed on input bit 06, and then examine if closed on input bit 07. The result of that AND operation is assigned to output byte 1, bit 4. And if we wanted to look at this in a physical manner, we have this examine if closed and examine if closed. So if both of these inputs are closed, then current will go through here and energize the output. Here's another example with more logic, and this is just a series of ANDs. So we have sensor 1 and sensor 2 and not sensor 3 and sensor 4. The only way that this motor will come on is if these bits are 1, 1, 0, 1 in memory. Whenever inputs are combined in parallel, that's the equivalent of a Boolean OR operation. We have byte 2 bit 6 or byte 2 bit 5. If either one of these is a 1, then this evaluates to true, and so a 1 is assigned to output memory byte 2 bit 2. If we want to look at it physically as an electrical circuit, if either one of these is closed, we have examine if closed. So if either one of these is closed, then current will flow through and energize the doorbell. We can combine Boolean operations. Here we have either input 1 or input 3 and input 2. Now if this OR operation evaluates to true and this instruction evaluates to true, then the output has a 1 written to that bit. Start-stop circuits are common in order to latch an output. Here we have normally closed momentary contact button for stop and a normally open momentary contact button for start. Now when we press start, the output memory byte 1 bit 1 will have a 1 assigned to it, and then when we let go of start, then this OR operation is going to still evaluate to true because this memory bit had a 1 set to it. And so just a momentary contact on the start button will allow the motor, or whatever this output is, to run until the stop button is pressed. When the stop button is pressed, since this is an examine if closed operation and we have a normally closed button, then this will evaluate to false. So a 0 will be assigned to that input memory bit, and we have a false and whatever this is. It doesn't really matter because that's going to evaluate to false. And so the memory bit has a 0 assigned to it, which will eventually result in the output being turned off. It's possible to have multiple outputs on a rung, but the preferred way is to have the rungs in parallel and have multiple outputs shown here. This can also be extended to have different cases for multiple outputs. So here we have rungs in parallel that result in the bell being on if sensor 3 is on. Now if sensor 3 and sensor 2 are closed, then pump 2 and the bell are on. And if sensor 3, sensor 2, and sensor 7 are all closed, then output 1, pump 2, and the bell are all on. So output 1 requires all 3 of these because they're in series down to output 1. And again, you can have placement of outputs, multiple outputs on one rung, but it would be better to have them in parallel as shown in the previous 2 slides. Now there are 5 slides for you to practice this logic, and there's a picture of the ladder logic diagram and a table with the values for the inputs. And so I'll give you a second to pause the video and evaluate the result, and then unpause it and I'll tell you the answer. So go ahead and pause this one. Since we have true or false or true, then the result is true, and so output has a 1 assigned to it. Here's another one, and you can go ahead and pause it. And now the answer is true. Go ahead and pause this one and evaluate it, and then unpause for the answer. The answer is true. 2 more. Go ahead and pause. In this example, the output is going to have a 0 written to it because this and this or evaluate, the combination evaluates to false. And the final one, pause. This output has a 0 written to it because, or assigned to it, I should say, because this combination of Boolean operations evaluates to false. There is an instruction called not that can invert the value of the rung. If the value before the not instruction is true, then the value after it will be false, and vice versa. Here's an example of a way to do latching with, or 2 examples of ways to do latching with normally open push buttons. We have an examine if open for the stop button and an examine if close for the start button. And then once the fan starts, then it latches using this OR operation as shown here, these 2 rungs in parallel. Alternatively, we could use a set and reset coil. Whenever input 1 is true, then the output will be set, and it stays true even if this is let go of. So even if this goes to 0, this output stays set. So that's the function or operation of this set coil. And the way that output has a 0 assigned to it is whenever input 2 is closed, then the reset coil will clear the memory bit for the output. Just a couple more. Here's a negated coil, and this writes the inverse of the rung's value to the output bit. So this is an alternative to using the not instruction. The not instruction would be more versatile because it could be used with all manner of coils, whereas this is one particular type of coil. And that is the end of another video on ladder logic.